So to begin with, we want to find the limits and values at -5. They appear, the left-handed limit doesn't exist. The right-handed limit seems to approach -3, and the value of the function is also -3. If we do this at -3, right, x approaches -3, then the limit from the left appears to be -1. The limit from the right is 1 or maybe 1 point something, but whatever, close enough. And then the value of the function at the point is equal to 2. If we approach at 0, the limit from the left is 1, the limit from the right is 3, the value is 1. If we approach at 2, the limit from the left is what appears to be 3 point something, 3.9, I don't know, and the limit from the right is about 0.5, I guess. And there is no value of the function at the point, so that's the answer. Okay, for problem number 2, we want to find the limit of f of x is 1 over x as x approaches 0 from the right. We've already discussed that is infinity, and from the left you get negative infinity. Find the limit of this as x approaches 1 from the left and right. So what you should realize here is that this is a shifted version, shifted and reflected version of 1 over x. So for one thing, we could think about, trying to write this as x, in terms of x minus 1, because that's a clear shift. So you should recall from high school that if you take the argument, which in this case is x, and minus 1, you get a shift to the right. So let me comment this out and plot this thing. But we can't just write it that way, right? We can't just choose to change the function. So how do I get it in that form? Well, I factor out a -1. That'll make it look the right way. And you see that this is a shift to the right by 1, and then the negative value, the negative sign attached to the argument means reflecting about the y-axis. So if I plot this, you'll see that yes, okay, it is shifted over to the right by 1, and rather than having the swooping line over here, it has been reflected over here. So now we want to talk about the limits as x approaches -1 or 1 from the left and the right. Clearly, as we approach from the left, we get positive infinity. As we approach from the right, we get negative infinity. Okay. If we want to find these limits, again, we could graph them, but it's actually quite helpful to think about plugging in points that are slightly to the left and right of the value that we're talking about. So if I plug in, I'm approaching 1, so I want to plug in something slightly to the left of 1. Now up here, that's just going to be close to 2, and that's not terribly interesting or worth considering. But down here, we get close to 0, telling me that we're hitting an asymptote. And as I plug in numbers slightly less than 1, I will have negative numbers down here. So a positive number divided by a negative number is negative, and the bottom is going to 0, so we're going to infinity. So that means that as we approach this from the left at 1, we get negative infinity. Now what if we approach from the right? Well, in that case, this is still about 2, close to 2, and this will be some number close to 0, which is positive, so we will have a positive over a positive. That means that this goes to positive infinity as we approach from the right. Now moving on to this, if we approach 1 from the left, this will be close to 1, so not interesting. This will be close to 0, of course, so we're hitting an asymptote. And because of the square, it's just always positive, right? I don't even have to worry about the sign because the square is telling me that that's always positive. So I get a positive number close to 0, giving me an asymptote. So this is just going to approach infinity, both from the left and from the right, because the sign doesn't change. Okay. Now how about this as x goes to 3? Now from the left, I will choose numbers slightly smaller than 3. The square of them will be slightly smaller than 9. that means that the difference will be negative. And you should recall that the logarithm function is not defined for negative numbers, nor for 0. So in fact, there is no limit from the left. What about from the right? Well, I plug in numbers that are slightly bigger than 3, and that means that I have a square that is slightly larger than 9. That makes this a number that is bigger than 0, but very close to 0. And we should know that ln, let's go ahead and graph ln, just to make sure that the graph of ln of x is familiar. And there it is. You can see that as x approaches 0, the function goes down to negative infinity. That should be familiar from high school. So as we approach from the right, the limit is negative infinity. Now for the next problem. We want to find the asymptotes of this. That's where the denominator is 0. If you factor this, you get x plus 2, x plus 3, and you would need to factor the numerator as well, but in this particular example, the factorization of the numerator, here, let's write that somewhere. The factorization of the numerator is x minus 2x plus 1. Oh, no, it's not. This the numerator doesn't factor well. But in any case, we can tell that you're not going to get an x plus 2 as a factor up here because it doesn't factor well. If it did, we could identify it. But you're not going to get an x plus 2 or an x plus 3, so no factors cancel. And therefore, the limit, the vertical asymptotes really are -2 and -3, the zeros of the denominator.